You know, we use AI for pretty much everything these days. We ask it to help with our emails, plan our vacations, and answer those weird questions that pop into our heads at 2 a.m. We've come to trust it. But what if that's a mistake? What if, buried deep inside that helpful AI, there's a secret command just waiting for the right moment to activate?
I know, it sounds like something straight out of a spy thriller, right? But this isn't fiction. This is a very, very real threat in cybersecurity. And today, we're going to pull back the curtain and see exactly how a friendly AI can be turned into a hidden weapon, a digital sleeper agent. And look, don't just take my word for it. This quote comes directly from the OWASP GenAI Security project, and these folks are the experts. They're basically sounding the alarm, warning us that attackers can plant these hidden backdoors in AI models that just lie there, totally dormant and undetectable, until one specific trigger is fired. So how in the world is that even possible? Well, to understand how you build an AI sleeper agent, you first have to understand the weapon of choice for attackers, and it all boils down to one thing, something called data poisoning.
Think about it this way. An AI learns from the data you feed it, right? It's like its diet. Well, data poisoning is when attackers sneak corrupted, malicious information into that diet. By feeding the AI this tainted data, they can slowly, subtly twist its future behavior, create all sorts of dangerous vulnerabilities, or, you guessed it, install those sneaky, hidden backdoors.
There are a couple of main ways they can do this. The first, data poisoning, is like messing with the AI's education, feeding it bad info while it's still learning. But the second one, model poisoning, is way more direct. That's like hiding a virus right inside the AI's brain, the model file itself, that just springs to life the second you try to use it. So the attack can come from the AI's food, or it can come directly from its brain. Okay, so if we're going to defend against these kinds of attacks, we first have to investigate the crime scene. Where are the weak spots? When are these systems most vulnerable? Let's trace the life cycle of a large language model and pinpoint exactly where the bad guys can get in.
Turns out, pretty much every single stage of an AI's development is a potential entry point. In the pre-training phase, it's learning from the entire wild west of the internet. I mean, what a perfect place to sneak in some bad data. Then, during fine-tuning, even a tiny poisoned dataset can have a massive impact. Heck, even the final embedding stage, where words get turned into numbers the AI understands, can be manipulated. And this shows us exactly what those weak spots look like. Attackers can deliberately inject harmful data or use unverified datasets from really sketchy sources. And sometimes the vulnerability isn't even intentional. Think about users who input sensitive company info that the model then learns and could maybe leak later. Without proper safeguards, the model is basically just drinking from any data fire hose it can find, whether it's clean or not.
All right, so that's the theory. But what does the damage actually look like in the real world? Let's dive into a few of the scariest scenarios to see just how bad this can get. So in our first scenario, an attacker could turn a trusted AI into a full-blown propaganda machine. By just subtly poisoning the training data, they could make the model start favoring certain political views, spread totally fake news about a public health crisis, or even generate these convincing but completely false historical stories.
Or how about this one? Corporate sabotage.
Imagine a company creates hundreds of fake articles online, all claiming their rival's product is unsafe. Then they use that junk to poison a popular AI model. Now, anytime someone asks that AI for a product recommendation, it just confidently says, "Oh, don't buy that other product, it's dangerous." And it even cites the fake sources it was trained on.
And this is the big one. This brings us right back to our sleeper agent. In this scenario, the attacker isn't just trying to spread some bad info. No, they've poisoned the model to install a hidden command, a secret backdoor. To the outside world, the AI is perfect. It passes every test. It's helpful, it's accurate, it's safe. But it's hiding something. And then, one day, the attacker sends it. A specific, seemingly harmless phrase or bit of code. The trigger. And just like that, the sleeper agent wakes up. The AI's behavior flips, letting the attacker waltz past security, steal sensitive data, or even run malicious commands on the system. It is the ultimate stealth attack.
I know, it's a pretty sobering picture, but it's not hopeless. The good news is, the cybersecurity world is developing some serious counterintelligence strategies to fight back. So, how do you defend an AI from an enemy it can't even see?
Well, the first line of defense is just a really strict verification protocol. You absolutely have to know your data's entire life story. They're tools like ML-BOM, which is short for Machine Learning Bill of Materials, that act like a nutrition label for your data, showing you every single ingredient and where it came from. This means you have to rigorously vet all your third-party vendors and use version control to track every little change, so you can spot tampering and roll it back.
And there are some really powerful techniques you can use at different stages. While you're training, you can use something called sandboxing, which is basically like putting the AI in a secure playroom where it can't touch any unverified data. You can also do red teaming, where you literally hire ethical hackers to try and poison your own model to find its weaknesses. And then, once the AI is actually being used, a technique called RAG, or Retrieval Augmented Generation, makes the AI treat every question like an open book test. It forces it to find answers from a trusted, up-to-date knowledge base, instead of just relying on its own potentially poisoned memory.
At the end of the day, defense is an ongoing process. It's not a one-and-done kind of thing. It means putting in strict controls so the model can't just go out and access random data. It means constantly monitoring its behavior for anything weird. And it definitely means keeping user data and training data in separate buckets to avoid contamination. You just can never stop testing and validating what your AI is putting out.
Which really just leaves us with this one big, challenging question. An AI is like a mirror, right? It reflects the giant ocean of human knowledge we train it on. But that ocean, it doesn't just have facts and creativity. It's also full of malice and deception. So protecting our AI is, in a way, the challenge of protecting it from the very worst parts of ourselves.